So how do we see cells? How were the first cells seen? So no one knew that cells existed until microscopes were invented. So Hans Lippershey and Zacharias Hansen in 1590 are credited as developing microscopes. And we have different types of microscopes that use light or electrons to reveal different details of the cell. We have the light microscope that was solidified in 1644. We have phase contrast in 1955. Woo, that's a jump. Reflected light microscopes. We have fluorescence microscopes in 57, transmission electron microscopes in 31, and scanning electron microscopes. So you can see there's some that use light, some that use electrons. And these are some of the this is a light microscope. Have you guys ever used these compound scopes to look at things? Some people get to use them. And then this is the scanning electron microscope. You can see this is actually a scaled down version from its original, but you can see it's a lot larger machine. And the same with the transmission electron microscope. It's a lot larger machine. But you can still put it on a desktop. It's kind of exciting. So when we look at cells, we want to kind of have a perspective of what we're looking at. So when we look with our own human eye, meaning that there's no microscopes, we can see the largest organisms, which are like blue whales, and we can see redwood trees and sequoia trees. We can see those with our eyes, right? Some people are even able to see ants and frog eggs. You probably cannot see this level of detail on the ant with your eye. If you can, you're very special. But you can tell that it's an ant. You can see it. You probably can't see that level of detail. When we look at, let me go back because so that's like the centimeter level or the millimeter level you get down to when you're talking about insects and frog eggs. Okay, that's a millimeter level. But when you go down to look at light microscopes, they can actually see down to the micrometer level. Okay, so that's like 1,000 times smaller that they can see down to. And then when you start talking about electron microscopes, you're talking about getting down to like the billionth smaller level. So you're getting really, 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 really tiny, and you can still see it. So things you can see with electron microscopes are things like organelles within cells. You can see viruses, and you can actually start to see some of the molecules of life at this level. So you can study them by being able to see them. Cool. So when we take a look at the same organism, but we're going to look at different microscopes, it'll just give you an idea of what different images you can see. So depending on, same thing in life, like depending on what lens you put on to look at something, that lens is going to give you a different perspective, right? So it's the same thing with these microscopes. You have a different microscope, you get a different lens, you get a different perspective on what you're looking at. So here's for a phase contrast light microscope. It yields high contrast images of transparent specimens. So this is going to be the same organism, but we're going to look at it in different microscopes. So this is a reflected light microscope. It captures the light reflected from the surface. So now you're kind of seeing what's inside of it, and then you're seeing what the surface kind of looks like. So now you have a perspective of both of those. This is a fluorescent micrograph. It shows the fluorescent light emitted by chlorophyll in the molecule. And this is a transmission electron micrograph. All of a sudden, you're starting to see all this detail about the organelles that you couldn't see before. And finally, this is a scanning electron micrograph, and it shows the surface detail. Cool stuff.